In this video we're going to look at a number of ways of dehydrating copper sulfate crystals. The blue copper sulfate crystals that everybody knows is copper sulfate pentahydrate. In other words, CuSO4.5H2O. It's the hydrated form of copper sulfate. It contains 5 molecules of water of crystallization. And these can be removed either by using heat, so thermal decomposition, or by using a dehydrating agent such as concentrated sulfuric acid. In the first experiment we'll look at the thermal decomposition. In order to get those 5 molecules of water away from the copper sulfates, bonds have to be broken, so heat has to be supplied. So heating the crystals with a strong flame allows that water to be driven off by breaking bonds that the water has with the copper ions and the sulfate ion, and that water can be condensed, as you can see in the video, at the top of the tube. When water has been removed, the material left behind is known as anhydrous. So the white anhydrous copper sulfate is a residue. You can of course put the water back, and that is a highly exothermic reaction, and the color change from white to blue indicates the presence of water. Note, not all crystals contain water of crystallization. Not all crystals have 5 molecules of water of crystallization. Sodium chloride, for example, has none. The second way of removing water is using sulfuric acid. Concentrated sulfuric acid is a dehydrating agent. It will remove the elements of water, or as in this case it will remove water itself. Dilute sulfuric acid doesn't have this property. If you put some concentrated sulfuric acid on blue copper sulfate crystals and leave for just 20 seconds or so, you can see the pale blue color turning towards white, indicating anhydrous copper sulfate. The reason for this is that concentrated sulfuric acid is actually molecular. It contains covalent bonds. When water is added to concentrated sulfuric acid, the OH group, or one of the 2 OH groups, releases an H+. There's some bond breaking going on, some bond fission. H+ has to be present, of course, to be able to be measured on the pH scale. The resulting OSO3H- ion can also give up an H+ eventually. Adding water to acid liberates a great deal of energy. With sulfuric acid, it's always better to dilute concentrated sulfuric acid by adding the acid to water and not the other way round, so that steam doesn't form and potentially blow out the acid into your face.